What's up, guys? I'm catching up on my advent of code, and day 3 looked annoying. Day 4 looked nice, so I'm doing day 4 first. It's called Scratchcards, and each line gives us some winning numbers, like lottery numbers that we're going for, and our numbers, like the ones we scratch off of a lottery ticket. So we have to see not only are any of these in there, but how many of these are in there. With one extra step to get our score, they double. So our first match is 1, our next is 2 and 4, and so on. In their example, this one has a bunch of matches, like 83 is in there, 86 is in there. So each one doubling means we get 8 points, even though there aren't really 8 matches. Then the next don't have very many, but the total score is 13, just based off that first line giving us a big push. So I'm going to start with part 1 already typed out. I think I'm going to do this for most of my videos. You don't have to sit through the boring setup. You don't have to hear me click-clack on the keyboard, but I'll explain it, and then I'll lead into part 2, which is always the more interesting part. So our test data and our big data are the same pattern with just different size. We have a card number, and I'm throwing that out. I remember a few days ago we had one with a number at the beginning, and it was so much trouble, and I could have just used enumerate. Actually, in this part, we don't even need the number at all, so it's even less. Then, after splitting on the colon and throwing out this stuff, I split on the line, the bar, the pipe, whatever you call that symbol, and I take the wins, I called it wins, and the nums, I called it nums. You know, I took the integer of each one, but maybe we could have skipped it and kept them as strings. This has parsing each line, fair enough, and then we find how many matches. So we see, is num in wins, is one of these guys in here for each of these guys, and you can sum Booleans, you can add up to see how many were true, because true is 1 and false is 0. Then we have to find that doubling thing where it goes 1, 2, 4, 8, which is kind of a power of 2, but you have to minus 1 because it starts at 1 and not 2. And you also have to make sure you don't go negative, because if we got a negative power, it'd be like a half and it would mess up our scores. So that's pretty much it. I could have made like a function for one line and then used the sum of that applied to the whole thing, but instead I just used initialize, modify, classic procedural loopy stuff. And so if we do this on the test, it should be 13, and if I run it, in fact, it is. So let's run this on the big data, which is, I think I called it data, and it gives us 28538. Let's see. Yeah, that was right. So let's get to the good stuff, part 2. Part 2 says, oh, you know that doubling thing? That was a mistake. Throw it out. We have a new way of scoring. And the way of scoring is that the cards give you more cards. So like if I open card number 1 and it has a couple points, then I get another of card 2 and 3 and 4 and whatever. In this case, it says if card 10 were to have 5 matches, then you get an extra 11, 12, 13, 14, 15. And so the 11 does even more. So if the 11 had 3 matches, then it would do the next 3 after it, and then it would do it again because we had a copy from the 10, and it might have more copies from the 9 or whatever. So this really explodes in work. It's doing a lot of stuff again and again, and there are basically 2 ways to handle this kind of problem. You could use caching, C-A-C-H-E, cache, is when you do work and you remember what it was because it's going to come up again. So I could say like, okay, card 11, after figuring out the matches, it was 3, and if I ever need to look up card 11 again, I've got it in the cache. That's pretty cool. However, I'm going to skip that and do something slightly easier, because instead of saving the result, you could just use it again now if the situation allows for it. And that's what's going on here. They always look forward. So like 10 adds more to 11, 12, whatever, but it never goes back to 2 or something like that. So whenever I'm on a card, I know this is it. I know I'm not going to have to do more later. So when I'm on 11, it may have some copies from the previous guys, but it's never going to come to card 30 and say we added another 11. So when I'm on 11, I'm just going to do it a bunch of times now, or really just do it once and multiply, instead of remembering in case I need it, because I won't. Okay? That's just because of the specifics of the problem. We got lucky that it worked that way. So in this case, by the way, the numbers are going to be way higher, because like this card is going to duplicate a bunch of these, and then this one might duplicate a bunch of these, and then even if you get a 0, it slows it down, but it's still huge numbers. Like the test value for this one is going to be 30 instead of 13 for the other guy. So let's do some code. I'm going to copy part 1 because it's mostly the same structure in part 2. And then I'm going to say let's do 2 on the test, but not yet. Let's see. We're going to go through the lines, but this time I'm going to enumerate because I need to know where we are. Like if I'm on line 10, I have to know that I'm on line 10. And enumerate the wonderful Python function that I would really miss if I went to another language and they didn't have it. I know a lot of languages do. Rust has like .enumerate methods and so on. The parsing is the same. We have to figure that out. The matches are the same. We have to figure that out. The score, I'm pretty sure we don't need that, but I'll comment it out just in case we need to bring it back. And then we have to look forward. So if I'm like on line 9, I have to say, okay, 10, 11, 12, get a copy. And so we have to do a little forward looking inside of each step. So I'm going to say for offset. That's a good name. Offset is like the deviation from where we are currently. Like I'm looking forward 2 or I'm looking forward 3. Okay. For offset in range, I'm not doing 0, so I'm going to 1 to offset plus 1. Okay, because I'm not looking forward to myself, even though ranges usually start at 0. And then I'm going to say like, oh, copies of I plus offset, meaning if I'm on 9, I'm looking to 9 plus 1, or 9 plus 2, or 9 plus 3. Bumps up by, well, you could start out as 1, but remember that you yourself have also been copied. So like if I find that 9 adds to the next 3 guys, but 9 happens 3 times, well, I don't really need to do it 3 times. I can just say, oh yeah, just use the copies of myself as however many the result is going to be, instead of actually doing it 1 and then 1 and then 1. Okay, and I think they have a line in there about how like they're not going to look forward off the edge and they're going to be safe, but I don't trust it, so I'm going to say like if I plus offset is less than ln of whatever, you know, just to be sure. This is by far my least favorite thing in programming, is like making sure you don't go over the edge. In fact, that's why I didn't want to start day 3. When I looked at day 3, it's about a grid and you're looking for the neighbors, but if you're on the edge, you can't look off the edge, and if you're on the corner, you have 2 ways you can't go. And I just thought I would do day 4 first. So I've been talking about this copies thing, but it doesn't exist, so I'm going to start it up here. Copies is a parallel list. So like we've got a list of all our lines, and then next to it there's going to be a list of how many. So like, oh, you happen 1 time, you happen 5 times, you happen 6 times, whatever. So it's all going to start at 1 times however many there are. Or you could do like a list comprehension. You could say like 1 4-line in lines. That would actually be cooler, but this works. And then you return, not score, because there is no score, You return not copies either, because they don't care about which one. Like if I had 1 1 and 5 4s and 0 5s, they don't actually care. They just care about the total. So we return the sum of copies. Now let's do our test, and it should be 30. Let's try it. Oh, what did I mess up? For offset and range, 1, 2, offset, I don't mean offset plus 1, I mean matches plus 1. Matches is how many matches we got, and that's how many times you look forward to the next couple lines. And that was in fact 30. Now let's do it for the big data, which is 9425061. Let's see if that was the thing. Yes. When I did this first, I got a way bigger number because I was doing it wrong, and I knew that that wasn't it. Like I saw some giant 20-digit number, and even though I put it in here and hit submit and got the wrong answer message, I knew right away that, you know, they wouldn't ask us to do something that crazy, or would they? But that's it for today, or at least that's it for this day. I might do 2 in 1 actual day to catch up for the Advent of Code days that I missed. Thanks.